Alright, here is standard number 4, beats and Doppler. I did a screencast before, but accidentally did one from the quiz, so I did a different problem this time. It's problem 16.72, which reads, a bat flies towards a wall emitting a steady sound of frequency 2 kilohertz. This bat hears its own sound plus the sound reflected by the wall. How fast should the bat fly in order to hear a beat frequency of 10 hertz? So here I have 2 kilohertz, which is obviously 2000 hertz. The beat is frequency 2 minus frequency 1, which we realize is 10 hertz because it says it in the problem. We're going to use this equation in a few different ways. The frequency of the listener equals V plus V listener over V plus V source times frequency of the source. So the frequency of the source is the one source, and then frequency of the listener is listener 1. So the velocity of the source is the velocity of the bat, negative. And then the velocity of the listener is 0. So we can use these, plug them in there to get this. And then we have the frequency of the second source equals, which is the sound bouncing off the wall, equals the frequency of listener 1. The velocity of the source is 0 here, and the velocity of the listener is the velocity of the bat. So here we have FL2 equals V plus V bat over V times FS2, and we can plug in this right here and do this. Okay, so from there we get this FL2 equals V plus V bat over V minus V bat times FS1. 10 hertz is equal to FL2 minus FS1, which equals V plus V bat over V minus V bat minus 1 times FS1 because of distribution or whatever you call that, basic algebra. So that equals 2 times the velocity of the bat over V minus V bat times frequency of the source. So from that, we switch it around a little bit, get V bat to equal all of this, plug in some numbers, and get the answer, which is how fast the bat should fly in order to hear a beat frequency of 10 hertz to be 0.858 meters per second.